Hello friend, and today I'm going to show you a simple numerical problem on SFD and the BMD. SFD stand for shear force diagram and BMD stand for bending moment diagram. How can I draw SFD and BMD diagram in simple supported beam with point load? I will show you a simple numerical problem and show you that how can I draw the SF shear force diagram and the bending moment diagram. Let's see one example. Here we can see that it is a simple supported beam. Here one point load is here. It is a simple supported because two end is supported. One end is A, another end is B. Then the supported at B is, we can take RB, and here we can take a supported at A. Another three is in this to support the total load carry of the beam. Here we can see that the total load carry of the beam is equal to what? The total load carry of the beam is equal to how much? The is equal to this one load, is equal to this one load, is equal to this one load. So you can easily show this one is 5 kilonewtons, this one is equal to 10 kilonewtons, and also this one is equal, this one is 10 kilonewton. So here we can see that how can I find out the SFD and the BMD? Before we going to find out the or draw the SFD and BMD, first of all we know that the how much the value of the reactions RA and RB. So here we can easily write here RA plus RB is equal to how much? RA plus RB is equal to total load. That means 10 kilonewton plus 5 kilonewtons, and again the 5 kilonewton, 10 kilonewton. So therefore is a 25 kilonewton. This total load kilonewtons carry by the two support A and the support B. Then after that write this equation number 1. Then another equation we have to need to find out the RA and RB. How can I find out the RA and RB? By the law of moment. What is the law of moment? Law of the moment means if these two force is upward directions, this means simple supported at point B in upward directions, and point A is also the upward directions, and the another three force 10 kilonewton, 5 kilonewton, and the 10 kilonewton is downward direction. This downward direction, due to these downward directions, beams tend to rotate in the clockwise directions. I think you know, understand what I'm telling you. And this simple supported, that means reactions B, due to this support, beam is try to rotate in the anti-clockwise directions. Then if we write the clockwise movement equal to the anti-clockwise movement, then we can easily find out the reactions RA and the RB. How can I take a moment? So let's see. Taking a moment about point A, taking a moment about point A, this point we have taken a moment about this point. How can I write this moment? That means this one force means RB is the downward upward directions, and RA is also the upward directions. Then what will happen? Then we can easily write the RB into what distance between the, if we stand from this point, how can I take this moment from this point? Because of, if your right hand side all the forces are acting over the beam, then you can take a moment about point this. Then RB is upward directions. How much distance from the point A is 3? It is clear. So we can write a moment RB into 3 is the another moment this one moment is the anti-clockwise moment. So therefore clockwise moment equal to the anti-clockwise moment. Then another force, 3 force, is create a clockwise movement, that means these directions. So clockwise movement equal to the anti-clockwise movement. Then this force 10 kilonewton, this one is 10 kilonewton into acting at a distance from point A is equal to how much. You can see here, we can easily understand the distance 10 kilonewton, this force, the distance from the point A is equal to 2.5. So we can easily write force into distance 10 into 2.5. Again, plus, again also we can see that 5 kilonewton loads acting in the downward direction at a distance from A is equal to how much? 1.5. That means 5 into 1.5. Again, plus, again this 10 kilonewton load is the downward directions. How much distance from the point A? 0.5. 10 into 0.5. Just it is a simple calculations. We can easily find out the this value. What is the value of this? This 10 into 2.5 means 25. Then 5 into 1.5 means 7.5, and the 5. Then 37.5 we can easily write here 37.5. So RB into 3 is equal to 37.5. Therefore we can easily write value of RB is equal to how much? The value of RB is equal to what? 37.5 divided by 3. This one is equal to how much? This one is equal to 37.5 divided by 3 is equal to 12.5. Nothing else, it is 12.5. So RB is equal to 12.5. So taking a moment about, according to the law of movement, we can easily find out the value of RB from these equations. And another equation we have already write here, this one is equal to RA plus RB is equal to how much? Is equal to 12.25 kilonewtons. So RA is equal to, we can easily write RA is equal to 25 minus 12.5 is equal to how much? Is equal to 12.5. So I think you have understand. How can I find out the reactions RA and RB? It is a simple way. First of all, we take a moment about any point. Say here I can take a moment about point A. Also you can take a moment about point B. Then you can get same value. And again we can write RA plus RB is equal to this one equations, and putting the value of RB or RA, then you have getting the value of RA and RB in this way. There are the many methods we can find out the RA and RB. So it is in general method we can find out the RA and RB this way. After getting the value of RA and RB, what we will do for SFD and BMD? Then find the value of SFD, means shear force value. Then we have to find out the BM, means bending moment value. Then this value are putting this diagram, then we get the final result. So how can I get the value of SFD and the BMD? First of all, find out the SFD. Here we can see that for SF diagram, here we can see that we have already find out the RA is equal to, here is what? RA is equal to 12.5, we have already find out. Then here RB is equal to how much? RB is equal to 12.5. So for SF diagram, here some problem is seen, so therefore for SF diagram. So here we can see that. Let's see. Then SF at SF at B is equal to, is understand the SF at B is equal to 12.5 is upward directions. And upward directions we have get the positive, and the downward directions we have got the negative. Negative. And SF at C is equal to how much? So here we can see that SF at C is equal to 12.5 is upward directions because of the reactions of RB. This one again 10 kilonewton is downward, minus 10 kilonewton is downward. So it is simple calculations 2.5 SF at C. Again SF at D is equal to how much? 2.5 at C. If we take a C here, and we can here take a D here, here we can take a E here from here. So at D is equal to how much? Then we have already find the SF at C is equal to 2.5. Then D is equal to what? 2.5 minus 5 kilonewton is downward directions. So minus, we have taken downward directions is negative. So simple calculation minus 2.5. Again SF at E is equal to how much? 2.5 is the downward directions, and E is 10 kilonewton downward, is 12.5. And SF at A is already have, we have know that 12.5. So this value and this value is equal to, must be same. So 12.5. Similar way, in similar way, we can find out the moment. When we have draw the bending moment diagram, you need to have find out the value of the bending moment for every point. This way we can find out the value of the VM. Let's see. For BM diagram, here we can see that for BM diagram we can see that here BM at 0, BM at B is equal to what? BM at B is equal to 0, because of when you find out the BM from any fixed point, so it must be 0. Then BM at C is equal to how much? If I take a point C here, if a point D here, and if I take a point E here, then BM at C is equal to how much? BM at C is equal to 12.5 into 0.5, because of this one is equal to how much? 12.5 we have already find out, but right here just for your betterness to understand. Then the BM at C is equal to 12.5, and how much distance from this one is equal to 0.5. So putting this value BM at C, this one is equal to how much? 12.5 into 0.5 is equal to 6.25. This one is equal to 6.25. And BM at D, how can I write the BM at D? BM at D is equal to 12.5 here into how much distance? 1.5. So again 10 kilonewton, this one is the downward directions here, and how much distance from the D is 1. That's why 10 into 1. This one is equal to how much? This one is equal to how much? This one is equal to 18.75 minus 10 is equal to 8.75. Simple math, this simple numerical problem, a simple equations. Again, similar way, we can easily find out the BM at E. Then BM at E is equal to how much? Again, you have to take a moment about point E, then 12.25 in how much distance from the this portion? 1 plus 1 plus 0.5 means 2.5. Again, this 10 kilonewton into 2, again 5 minus 1, 5 minus 1 is equal to 6.25. So this way we can easily find out the BM at E. Again, find out the BM at A. I have told you that it is a fixed, when they find out the bending moment about any fixed point, this is the fixed point. That means it is a fixed end. Because of fixed end, it is a simple supported beam. When you find out the moment about a fixed point, then we have already seen that in case of point B. In case of point B, what? BM is equal to 0. So similar way, BM at A must be 0. How can I write the BM at A? Here we can see that BM at A 12.5 into 3, because of here 12 point load here and distance is equal to 3. Then again this one to 10 into distance is equal to how much from this point? 2.5. And 5, how much distance? 1.5. Then again 10, how much distance? 0.5. It is simple calculate. When you calculate this one, we can get the value of the 0. So this one also we get the value of 0, or otherwise you can easily write BM at A is equal to must be 0. So you can also write 0, or you can also calculating the value, then you can get the value of 0. If we'll to right way, then you can get the value of 0. If any wrong during the taking of moment, so you can't get the value of 0. Anything else, positive or negative, whatever. So if you take a moment in right way, then it must be 0. So you can get the value of 0 this way. After that, what we will do? Then we have draw the SFD and the BMD. Let's see how can I draw the SFD and the BMD. So it is a loaded beam. Here we can see that it is a loaded beam, and this loaded beam we can take a straight line from this point. You can take a straight line from this point. You can take a straight line from this point. You can straight line from this point. You can take a straight line from this point. You can take a straight line from this point. Straight line, not a curved line. Here some taking here see some curved line, but not a curve, actually a straight line. Then take a baseline. You can take a on baseline. Then putting for SFD, first of all draw the SFD. First we'll draw the SFD. Then putting all the value SFD, go to the previous slide. Then here see we can see the value of SFD. SFD is equal to what? SFD is equal to 12.5, SF at C 2.5, SF at B. Then go to the next slide, SF at B. SF at B is equal to 12.5. So we take any scale, suppose here. So if I change, you can really understand the SFD and the BMD. Then take any scale here. This value is 12.5. Suppose 12.5 is equal to 2 centimeter. 2 centimeter. Then no force between the B and C. Take a C. You can D and you can take a E. So draw a take straight line. No force. And what is the value of SF at C? Again go to the slide. So the value of SF at C. SF at C is equal to 12.2.5 to 2.5 means is smaller 2.5. This one 2.5. This portion is 2.5. Then no load between the C and D. This one C and this one D. Then again I draw a straight line here to here. But at C, the value of SF at C is equal to how much? Minus 2.5 means it is the bottom line, means reference line, zero line. Then draw a negative line. This portion is also a minus 2.5. Minus 2.5. And again, no load between E, D and E. Then draw a straight line. What is the value of E? If we see that, we can already find out the value of E at 12.5. Then again draw the minus 12.5. So minus this one is equal to minus 12.5 and just join this line. So this block is called the straight line, not a curve. This block is actually SFD and this one is the SFD. SFD. So this way we can easily draw the BMD also. So how can I draw the BMD diagram? Let's see. After the drawing SFD and BMD, then draw the BMD. How can I draw the BMD diagram? Let's see here. We can erase this one. You must be draw SFD and after that draw a BMD. First draw loaded diagram. After that be SFD, then draw a BMD. You have to draw the BMD as a first of loaded beam, then draw SFD and then draw the BMD, and below BMD must be draw the below the SFD diagram. So again we take a straight line. Again we take a straight line. This one, this one, this one, this one, and this one. Then what is the value of the BM? And take a reference line. This one the reference line. The BM, the value of the BM, we can see here, the value of the BM at B is equal to 0, at A is equal to 0. The end point is equal to 0, then C is equal to how much? Value of C is equal to 6.25. Then putting the value of C at 6.5. So change a color, then you can really understand what I am telling you. Then easily you will really understand the value of the BM. This one is equal to 0. This one also 0. The value of C is 6.25. This means this one. This portion is going to draw the side straight line. This is the value of 6.25. Then after that, what is the value of the BM at point D? Let's see what the value of D at point D is equal to 8.75. So slightly higher. 6.25 and 8.75, slightly higher. So this is slightly higher. This is 8.75. Again, what is the value of BM at E? 6.25. Again 6.25. Then again you draw this line. It must be here, means this line. Not need to this line. From your reference, I have draw this line. No need to draw this line. And so this. And again, BM at A is already find out the 0. And I can draw a straight line. This is the BM diagram. This is the BMD. This So this way we can easily draw the SFD and the BMD. This way you can easily draw the SFD and BMD. It is a simple numerical problem when you draw the SFD and BMD. I think you have understand how can I draw the SFD and BMD. Due to shortage of pages, so first of all here we draw the SFD. Here we can draw the SFD, and after that draw the BMD below the SFD. Draw the BMD. So when you draw your notebooks, must we have first of all you draw the dotted diagram, means this one, then draw the SFD and draw the, after that you draw the BMD diagram. So this way you can easily draw the SFD and BMD in simple supported beam. So I think is understand it is a simple problem and the simple numerical problem. I think you have understand and try to understand. If any problem, I can also upload the many videos SFD and BMD and see. So thank you, student.